On guys, in this video we are going to see how to find out the operation mode of BJT. There are two methods we can use. The first one is we assume this is in active mode and solve for this one, like solve for VC and VB. If the VC is greater than VB, this is in active mode. If it's not, it's in saturation mode. And also we can find out this one using saturation mode. In saturation mode, what we have to do is we have to calculate this beta first. Beta first is beta minimum, and to find out this one, we have to find out IC and IB, and if the ratio of this one is beta first, and if it's less than beta, then this is in active mode. Okay, then if it's not, it's in passive. Saturation mode. So there are two methods we can use, but here we are going to use this active mode. To use this active mode, but if we assume this is in active mode, then this base emitter voltage is going to be 0.7 voltage right here. Now this is base, so we can call this one base current as IB. Here we are going to apply KVL. If we apply KVL, since this current is going from negative to positive, this is going to be negative 2 voltage, and this plus IB times 10k, IB times 10k plus 0.7 should give us 0. And from this one we can solve for IB. Negative 2 plus 0.7, that's going to give us minus 1.3. So this is going to be 10k IB is equal to 1.3. If I move this one to the other side, it's 1.3. And then IB is going to be equivalent to 1.3 divided by 10k, and that is equivalent to 0.13 milliampere. Now we have solved for IB. Our purpose is to find out the VC, because VB is already known. VB is 0.7. We have to find out VC. To find out the VC, we have to use this equation that VC is equal to VCC minus IC times RC. Now VCC is this top voltage right here, 10 voltage. That's already known. IC, we don't know that. RC is this one. So to find out this IC, there's a formula for that. IC is equal to I forgot to mention the beta. Beta is equal to 100 here. IC is equal to beta times IB. So we know the IB here, beta is 100, then 100 times IB is 0.13, that's going to give us 30 this milliampere. So 13 milliampere is IC. Now to find out VC, now we just have to plug it in this equation. We already know VCC, that is 10 voltage, minus IC is 13 milliampere, multiplied by RC, that is 2 kilo ohm, and let's get rid of this ampere. Milli and kilo cancels each other, so this is going to be negative 26. Negative 26 plus 10, that's going to be negative 16 voltage. VC is negative 16 voltage and VB is 0.7. So from this one we know that VB is greater than VC. Now in order to be in active mode, VC has to be greater than VB. Here we are getting VB is greater than VC. This is not in an active mode. If it's not in active mode, it means this is in saturation mode. So this BJT is in saturation mode, and that's how we do that. I hope you guys find this video helpful, and if you are trying to learn electronics or circuit analysis, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.